In this video, I'm going to summarize our graphical models. Here we have several position versus time graphs, or just simply position graphs. If you notice, all of these are linear. A linear position time graph implies that the object has a constant velocity. The slope of the line is the velocity of the object. For the red lines, A, B, and C, all three of these lines are sloped upward. This tells us that the object is moving in the positive direction. The slopes of those three lines are positive, and so it has a positive velocity. The three green lines, D, E, and F, are all sloped downward. This implies that the object is moving in the negative direction. All three of these green lines have negative slopes, therefore they represent objects with negative velocities. The three black lines, G, H, and I, are horizontal. A horizontal line has a slope of 0. That means the velocity of the object is 0. So the object represented by the line G is at rest at about the 8.5 position. The object represented by H is an object that's at rest at the origin, 0, and the object represented by I is an object that's at rest at about the negative 7.2 position. So it doesn't matter if the line is above or below the x-axis. What you look for in position time graphs is how steep the line is, and is it moving upward like A, B, and C, or downward like D, E, and F. So these all model objects that are moving with a constant velocity. If the velocity of the object is not constant, its position time graph will curve. The general rule for the curving position time graphs are the steeper the line or graph is, the faster the object's moving. So the red lines A and B start out flat and end up steep. B starts out flat and ends up steep. So both A and B represent objects that are speeding up. The difference in A and B is that object A, since the graph goes downward, is moving in the negative direction and speeding up, while B, since the line goes upward, is moving in the positive direction and speeding up. C and D, the green lines, represent objects that are slowing down. C starts out steep and then gets flat, implies it starts out fast and then gets slower. D starts out steep and then flattens out, so it's also representing an object that's slowing down. The difference in C and D is that object C is moving in the negative direction because the graph is going downward. D is moving in the positive direction and slowing down because the graph is moving upward. It doesn't matter if the graphs cross the x-axis, that's simply a place on the number line. So B started out at the negative 8 position, went to the negative 7, the negative 6, the negative 5, and 4, and 3, and 2, and 1, crossed the origin, and moved into the positive side. So position time graphs, you look at two things. Is the graph rising or falling? If the graph is rising, you're moving in the positive direction. If it's falling, you're moving in the negative direction. And then you look at the steepness of the graph. The steeper it is, the faster you're going. So linear graphs don't change their steepness, which means a constant speed or velocity. Graphs that get steeper imply the object speeding up. Graphs that get flatter imply the object slowing down. Now it's easy to confuse those with velocity graphs, so you have to be really careful here. The velocity graphs that we'll encounter will all be linear. Linear velocity graphs imply a constant or steady acceleration. The slope of a velocity time graph is the acceleration. So the red lines A, B, and C are all horizontal, they have a slope of 0, which means the acceleration of the object is 0. If the acceleration of an object is 0, then that object is moving with a constant velocity. So the velocity of the object represented by graph A is 6 units, 6 meters per second in the positive direction. The velocity of the object represented by B is 0, which means it's at rest. The velocity of the object represented by line C is negative 6.5. This implies that object is moving with a steady speed in the negative direction. Lines G, H, and I all have positive slopes, which means you have positive accelerations. Lines D, E, and F all have negative slopes, so you have negative accelerations. Now, having a positive acceleration does not necessarily mean that you're speeding up. In fact, line I has a positive slope, so a positive acceleration, but it's slowing down. Its velocity is going from -9 to -8 to -7, -6, -5, -4, but its speed is going from 9 to 8 to 7 to 6 to 5 to 4. It is slowing down, but moving in the negative direction. G is speeding up while moving in the positive direction. Its velocity goes from 5 to 6 to 7 to 8 to 9, so it's getting faster. H is interesting. It starts out with a negative velocity and then gets a positive velocity. That means it started out moving in the negative direction and then started moving in the positive. It changed directions. Crossing the x-axis in a velocity graph implies that the object is changing its direction. The object represented by D is slowing down while moving in the positive direction. F is speeding up while moving in the negative direction. The velocities are negative, so it's moving in the negative direction, but speed is the absolute value of these, so going from 3 to 4 to 5 to 6 to 7 to 8 is actually an increase in speed. So here's what you have to consider when you're looking at velocity time graphs. If the graph is above the x-axis, that's where your positive velocities are. That means you're moving in the positive direction. If your graph is below the x-axis, those are negative velocities, which mean you're moving in the negative direction. Whenever a graph crosses the x-axis, moving from negative to positive or positive to negative, that implies the object changed directions. Now, to know if the object is speeding up or slowing down, you could look at the absolute values of the y-coordinates, the velocities, or you could keep a simple little process in mind. If your car's speedometer is moving away from 0, then you're speeding up. And when your car's speedometer is moving towards 0, you're slowing down. Well, that's also true with velocity graphs. Graphs that move away from the 0 velocity, which is the x-axis, like G is moving away and F is moving away, those represent objects that are speeding up. But graphs that are moving toward the x-axis, the 0 velocity, like D and I, those imply slowing down. So line E, is moving in the positive direction and slowing down, then it starts moving in the negative direction and speeding up. H is moving in the negative direction and slowing down, then turns around, moves in the positive direction, and speeds up. It's very easy to get velocity graphs and position graphs confused, so you have to really be careful and consider what those y coordinates represent.